so when we're actually laying out the curve, and we will do a field exercise to lay out the curve, what we're going to do is we'll have, whoops, sorry about that. We'll have the beginning point that we have out in the field set up. We know where the end point is, and we know where our PI is. What we'll do is we'll actually set up on the PI point, and we'll backside the beginning point and zero set that. We will figure out in our calculations for our own curve, we will figure out a radius that we'll build out in the field, and we'll figure out the tangent length, and we'll set the PC. From there, we'll also set the PT from setting up initially at the PI point. Now, once we do that, we're going to move to the PC point, and we're going to use the incremental deflection angle. That's what we're going to be using this year, is the incremental deflection or incremental chord distances to figure out how our curve is going to work. Now, when we go out in the field and we start setting our curve, what may or may not happen is when we start setting out, if our curve doesn't actually hit the point we set for the PT, then we have a misclosure, or it's also known as a falling distance. So go ahead and read through this. This tells us how we will set up out in the field. Again, the PowerPoint's posted on Blackboard, but we're going to be using the incremental chord distances with deflection angles and figure out how our curve works. All right, this is a typical how the field notes work. So it starts out at the beginning, is down here on the lower end, and rises for our stationing. Something you should be aware of is how we're laying out curves. We'll be going over more of that in the future lectures, but whether we are curving to the right or curving to the left, that is really big when we start doing the chord calculations. All right, now with that, here is another example. It's on, again, it's in the PowerPoints, and it's also in the lecture notes. Let me show you here in the lecture notes. This is an example of locating the curve. The most common method of locating curve in field is by deflection angle. So in this one, we have the total chord distances that we're using. This is in metric. So there's a beginning point, but we still have to use the deflection angles. So instead of the incremental deflection angle in between, we are actually using the deflection overall. All right, so when we do this, we still have to figure out our initial subchord and our ending subchord and subdeflection angles. So review this example for the total chord method. Okay? So in this one, we'll have our stations and our deflection angles. All right. Now, I'm going to go back a couple of slides and let me go back to the PowerPoint. When we're talking about laying them out in the field, from here to here is the total deflection angle. Okay? The subdeflection angles are going to be these incremental pieces in between. All right, just FYI. So we'll set up and turn the angles there. All right. So I'm going to pause here, and then we're going to go over what your homework assignment is.